Okay, in 3.3, I'm just going to do pretty much the whole assignment here in case you had trouble with it. Find the c and the t intercepts. So that's like the x and the y intercepts. The x-intercepts, to make this be 0, x would, or t would have to be -2, would come out to be 0. If I put in 3 minus 3, that would be 0. And if I put in -5, this would be 0. 0 times everything would be 0. Now, if I want the whole thing to be 0, I'm going to put 0 in for the, if I want to find the y-intercept, I got to, or the c-intercept, I have to put zeros in for the t. So if I put zeros in, I get 3 times 0 plus 2 is 2 times 0 minus 3 is -3, and 0 in here leaves 5. So I got -15 times 2 is -30 times 3 is -90. So that's the y or c intercept, and the x or t intercepts are these. Number 6, oh, well, let's see. I see that a 4 goes into everything and a t squared. So I got 4t squared. And what would be left? Well, that would be t squared times 4t squared would be t to the 4th plus 3t times 4 is 12. T squared times t is t cubed. And then 4 times -10 will make -40. And the t squared's there. So I'm hoping I can factor this. See, this would be t times t, and to get -10, it'd be 5 and 2, and I want a +3, so how about +5 and -2 to make the -10, and I get -2t and +5t is 3t. So the t-intercepts, or x-intercepts if you will, either way, we got 0. We'll make it be 0. And so that happens to be the c-intercept also. That has a multiplicity of 2, but they didn't ask us that. And it looks like -5. We'll make it come out to be 0. And 2 would make it come out to be 0. Now I could have just graphed this, and it bounced at 0 and crossed at -5 and crossed at +2. And I could have seen those. And since it's at 0, 0, that's also the c-intercept. Okay, now it says graph. So I'm going to have to pull out my calculator here. And we get, let's see, what is it? X to the 3rd. I don't have it in here, so turn this one off. Come up here and do what we're doing. X to the 3rd. Let's see, where is it? Minus, subtract 6x squared plus x plus 28. Zoom 6. Oh, that doesn't look like a nice thing. It's kind of really close to -2, but not exact. And then it's questionable what's going on there. So I'm going to go zoom in at this place. Press enter. Oh, I'm going to zoom in again. Enter. Oh, it goes through there, which looks like that is about 4, and someplace that's not so nice. So it goes through 4. So x minus 4, I think, is a factor. So I'm going to actually divide x minus 4 into this. Now, I did this in class. X minus 4 divided into, I got that a little too high. Let's see if this eraser works. X minus 4 going into x to the third minus 6x squared plus x plus 28. So x times what makes x to the third? X squared. X squared times x is x to the third. X squared times negative 4 is negative 4x squared. Now I'm supposed to subtract, so I'm going to draw the line and change the sign. So now I can add like terms. These are equal and opposite, so they're gone. I got negative 6x squared plus 4x squared, which is squared. So I get minus 2x squared plus x plus 28. What would I multiply x by to get this? Well, it's going to be a negative 2x. Negative 2x times, and that is negative 2x squared. Negative 2 times that is plus 8x. Draw the line, change the signs. These cancel. 1x minus 8x is negative 7x plus 28. X times negative 7 makes negative 7x. Negative 7 times that, negative 7x. Negative 7 times negative 4 is plus 28. If I draw the line and change the signs and add like terms, I get 0. So it went in evenly. So this factors to x minus 4 times x squared minus 2x minus 7. Now, to get the exact zeros, I need to use the quadratic formula on this. So let me grab a piece of paper here so I got room to do it. And in class, I emphasized some of the problems with the quadratic formula. We've got x squared minus 2x minus 7 using the quadratic formula. It's the opposite of b, so the opposite of negative 2 is 2 plus or minus the square root. B is negative 2, and I got to do b squared, so negative 2 times negative 2 is plus 4. This number should always be positive, because if you square negatives, you get positive. You square positives, you get positive. The only time this would not be positive is if it was 0, and then it's neither positive or negative. And then I'm supposed to do minus 4 times a times c. Well, negative 4 times a positive 1 times a negative 7 is going to be a positive answer. I think of negative times a positive times a negative. And now I can just do the numbers. 4 times 1 is 4 times 7 is 28. Over 2 times a. And the other thing people mess up is, besides the sign here, is that it's 2 times this, and both this and this are divided by 2. A lot of people will try to cancel the 2's here, but if you put the 2 into this, that's fine, and call it 1 plus or minus, but the 2 still has to go into this. Square root of 32 over 2. Or you could leave it 2 plus or minus the square root of 32 over 2. You could say 32 is 16 times 2, and so you get the square root of 16, square root of 2, square root of 16 is 4. So you could call it 2 plus or minus 4 square root of 2 over 2. And now you can divide the 2 in there and you get 1. You divide the 2 in there and get plus or minus 2 square roots of 2. Any one of those are okay. And to solve graphically for the zeros. Now, they didn't ask you to the exact, but I want you to be able to do that. But if you just look at the graph, there's another 0 there. To find that one, I can say on the calculator, I can say second, trace or calculate the 0 that's between, I got to go to the left of it, there, and to the right of it, there, and then my guess is about there, and it says 3.828. That's one of these. 1 plus a square, 2 square roots of 2 is the 3.8284271, blah, 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 blah. The other one, if I go back to here, the other way to do it on a calculator, it's between -2 and -1. It's actually between -3 and -1. It's between the other ones too, but second, calculate the 0 between -3 and -1, and it's about -2, and it says it's -1.82847, probably 1, blah, 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 whatever. But that's what 1 minus 2 square roots of 2 is. So those are decimal approximations. These are exact. The other one was 4. Those are the zeros. Solve for the zeros. Okay. Now, the other thing, the reason I did the long division is because I want you to see how to do synthetic division. There's a shortcut to this. What makes this be 0 is 4. And we're dividing it into 1x to the third, -6x squared, 1x, 28. The important parts of this, well, if this is 1, this, whatever, if this was 2x into 2x to the third, there'd be a 2. It'd have to be 2x squared. So this, whatever this first number is, that's what the first answer is going to be up here. So we get that by just saying 1 plus nothing, plus 1 added to nothing is 1. And we've got this number. 4 times 1 is 4. We took -4 times 1 and got -4, but then we had to change the sign. Well, this, since I left this being plus 4, it's already plus, and we get -6 plus 4, or -6 plus 4, we get -2, which we got -2 times x had to be -2 up here. -2 times x, we don't really care because that cancels. It's the -2 times the -4, which made +8, but then we had to change the sign. So we do 4 times -2, which makes -8. That's the +8 with the sign change. And we added 1 and a -8 to get -7. That's what we're going to get here. And that's also the next term. And if we take 4 times -7, we get -28. We took -7 times -4, got +28, and then had to change the sign to add. And we add here, and we get 0. And it went in evenly. We got 1x squared. 1x squared, this was x to the third, dividing it by x minus 4, lowers the power by 1. This was x squared, so it goes down to x. This was x, goes down to a constant. So we got 1x squared minus 2x minus 7. So this is how synthetic division is done. Okay, that was 8. Spent a lot of time on 8. The rest of these are much faster. The book shows one way to do these. I'm going to show you another way. We're going to use our knowledge of graphing to solve these. This goes through +5. It goes through -1. In fact, it bounces at -1. And if that's minus 1, x equals 0, probably about there. There's the y-axis, and then 1, 2, 3, 4, 5. So it bounces at minus 1, and it goes through because it's multiplicity 1, multiplicity 2. Bounces at minus 1. It's a double zero, single zero, so it goes straight through. And this is x times x times x. That's x to the third with a positive in front. There's no negative. So if it's a positive x to the third, it starts down, goes up, and since it bounces here, it's going to go up and bounce, and then come down, and then it's going to go straight through. Now, if I were saying y equals this is what the graph would look like. And so I'm looking for when the y coordinates are bigger than 0. Well, y is this direction, and all these y coordinates on the graph are less than 0 below and bigger than 0 above the x-axis. So if I want it bigger than 0, the only part of this graph is this part that's greater than 0. And it happens when I'm solving, I'm trying to figure out the x's that make it greater than 0. Well, these x's make the graph go up, and so the solution is for the x's that work are the ones that are greater than 5, or in interval notation, 5 and to infinity would make it greater than 0. 5 makes it equal to 0, so we don't include it. We don't have equal. Let's go to the next one. It goes through plus 4, straight through because it's multiplicity 1. Goes through minus 3, straight through multiplicity 1. It's only one of them. It's not squared. And it goes through minus 6. And it's x times x times x, which is x to the third. It's a plus x to the third. X to the third starts down. It has to go straight through, straight through, straight through. And we're looking for the x values that make this y value, because I'm graphing y equals this. The y values are less than 0. Y values here are below the x-axis, so they're less than 0. That happens for these x's. So from negative infinity up to negative 6. At negative 6, it's equal to 0, so I don't want that because it said less than 0 only. Between negative 6 and negative 3, the y values are positive. And then the y values are negative again from negative 3 to positive 4. Negative 3 to positive 4. The y values are also negative, so this expression would be less than 0. After that, the y values are positive. They're up above the x-axis, so we don't want anything where the y values are positive. So there's the answer. Okay, 31. A 0 at x equal minus 2 means the factor is x plus 2. A 0 at 1 means x minus 1 is a factor. A 0 at 3 says x minus 3 is a factor. And this curve, we could graph it, but it could be stretched or shrunk. And so I'm going to put an A there. And then if I put 0 in for all my x's, 0 plus 2 is 2, 0 minus 1 is minus 1, and 0 minus 3 is minus 3. And if I take those all times my A, I'm supposed to get, for y, a negative 4. So 2 times negative 1 is negative 2, times negative 3 is negative 6, or positive 6. These multiplied are 6. So if I divide both sides by 6, I find out A is negative 4/6 or 2/3. So my equation needs a 2/3 right here. Negative 2/3 times x plus 2 times x minus 1 times x minus 3. And that's an equation for this one. You notice it's degree 3 because it's x times x times x. Now I could multiply it out, but I don't. For as far as I'm concerned, you don't need to. Now I got to have 5 factors. Multiplicity of 2 at 3, so x minus 3 squared. Multiplicity 2, so it's squared. And at 1, so it's x minus 1 squared. Multiplicity 2 at 1. 1 makes it 0. And a root of multiplicity 1 at negative 3, so it's x plus 3. And it might be times something. And if I put 0 in for the x's, I'm supposed to get 9. So 9 will equal a times, putting 0 in for the x's, I get negative 3 squared, 9. 0 minus 1 is minus 1, squared is 1. 0 plus 3 is 3, squared is 9. So if I divide both sides by, see, I'm putting in 0. Oh, I don't need to square this one. This is 0 plus 3 is just 3. It's not squared. I get 9 times 1 times 3 is 27. So I'll divide both sides by 27. And a is 1/3. So I go back and write 1/3 there, and I have my equation. So 36, a single 0 at minus 2, so that means x plus 2. And at 3, so x minus 3, single, power 1. Triple at 1, x minus 1 to the 3rd. Times something is my polynomial, and it goes through 2, so I got to put 2 in for all the x's. So that would be 4a times 2 plus 2 is 4. 2 minus 3 is negative 1. And 2 minus 1 is 1. Cubed is 1. And that's supposed to come out to be 4. So this is negative 4. So I divide both sides by negative 4. And 4 divided by negative 4 is negative 1. So a is negative 1. (38), write a formula. Goes through minus 3, so it's x plus 3. Goes through minus 1, so x plus 1. Goes through 3, so it's x minus 3. And it went straight through, straight through, straight through, so none of these are squared or anything fancy. There might be something times it. And it goes through 0, 2. So instead of giving us the roots this way, we are just reading them off the graph. If we put 0 in for the x's, we get, and we're supposed to get 2. 2 equals a times 0 plus 3 is 3. 0 plus 1 is 1. 0 minus 3 is minus 3. So this is minus 9. So we divide both sides by negative 9. So a is negative 2/9. (40). So it's got y equals a x plus 2, bounces, squared, and x minus 3. goes through 0, negative 3. So if I put 0 in for the x's, I get 0 plus 2, 2 squared 4 times, put in 0 for the x, I got negative 3. And I'm supposed to end up with negative 3. So it looks like I need to divide by negative 12. So negative 3 divided by negative 12 is positive 1/4. And 44. Bounces at negative 3. So that's x plus 3 squared to be a bounce. Goes through 1, so it's x minus 1. Goes through 3, so it's x minus 3. And there's an a and a y. Goes through minus 2, 0 minus 2 on the y-axis. Put zeros in for x, I'm supposed to get minus 2. 0 plus 3, 3 squared, 9. 0 minus 1 is negative 1. 0 minus 3 is minus 3. 3 minus 3 times minus 1 is 3 times 9 is 27. So a is negative 2 divided by 27, and that's what I would put in here. And 48, last one in this one. Goes through minus 2. One time, straight through. Goes through minus 1, straight through. So one time, x plus 1. Goes through 4, so it's x minus 4. And this looks like an odd power. And it could be the fifth, or it could be just cubed. I'm just going to go with cubed to make it simple. There would be something a and y equals. It might be the fifth to make it look like this. You can graph with it and see if it should be 5. But if we go with 3, and the y-axis, y-intercept is 0, 4. So y is supposed to be 4 when x is 0. 0 plus 2, 2. 0 plus 1, 1. 0 minus 4 is minus 4. Cubed is negative 64. So that's negative 128. So we divide by negative 128. And that reduces to negative 1/32. But you could just put negative 4 over 128 in place of a. Okay.